Antimatter is one of the most fascinating topics in modern physics. It is often described as the mirror image of ordinary matter, with particles that have the same mass but opposite charge. The existence of antimatter was first predicted by Paul Dirac in 1928, and it was subsequently discovered in experiments. Antimatter particles are identical to their corresponding matter particles in all respects, except for their charge. For example, the antiparticle of the electron is called the positron, which has the same mass as the electron, but a positive charge instead of a negative charge. Similarly, the antiparticle of the proton is called the antiproton, which has the same mass as the proton, but a negative charge instead of a positive charge. When matter and antimatter particles come into contact with each other, they annihilate each other and release a large amount of energy. This process is called annihilation, and it is the reason why antimatter is so difficult to study and produce. When an electron and a positron come into contact, they annihilate each other and produce two gamma rays. These gamma rays have a very high energy and can be detected by sensitive instruments. Antimatter has many potential applications in areas such as medicine, energy production, and propulsion. For example, it is believed that positrons could be used to create high-resolution images of the body for medical purposes. In addition, the annihilation of matter and antimatter could be used as a source of energy, as it is a very efficient process that produces a large amount of energy. However, the production and storage of antimatter are very difficult and expensive processes. Antimatter can be produced in particle accelerators, but the amount produced is very small, and it is difficult to store. Currently, the cost of producing 1 gram of antimatter is estimated to be around $62.5 trillion, which is far beyond the reach of current technology. Despite the difficulties associated with antimatter, scientists continue to study it in order to better understand the nature of the universe. The study of antimatter has led to some of the most profound discoveries in physics, such as the symmetry between matter and antimatter and the nature of the weak force. One of the most interesting properties of antimatter is its role in the early universe. According to the Big Bang theory, the universe was created in a massive explosion that produced equal amounts of matter and antimatter. However, it is unclear why the universe contains more matter than antimatter today. This is one of the biggest mysteries in physics, and scientists continue to study it in order to better understand the nature of the universe. In conclusion, antimatter is one of the most fascinating topics in modern physics. It is the mirror image of ordinary matter and has many potential applications in areas such as medicine, energy production, and propulsion. However, the production and storage of antimatter are very difficult and expensive processes, and it is unclear why the universe contains more matter than antimatter today. Despite these challenges, scientists continue to study antimatter in order to better understand the nature of the universe and unlock its potential for use in future technologies.